Do you have time for one more question?
Absolutely.
Okay. NASA came out with their annual presentation on temperature the other day. They had one animation that showed temperature warming on a spinning globe. And we saw basically the reds and yellows over the whole globe, except for that spot on the North Atlantic, that stubborn blue spot.
Yeah.
So update us on that.
There has been a cooling in this one region of the North Atlantic, south of Greenland, over the past century that is without precedent over the past 1,000 years. So as the rest of the world is getting warmer, that region in the North Atlantic has seen some of its coldest temperatures on record in recent years. And it sticks out like a sore thumb when you look at the observations, which are red and yellow everywhere except for that blue patch in the North Atlantic. When you look at the mechanisms that could produce that sort of fingerprint, that pattern of cooling in that region in the face of warming everywhere else, really there's only one viable mechanism, and it's the slowdown of the so-called conveyor belt ocean circulation pattern. That global conveyor belt, that so-called thermohaline circulation, popularized, of course, in the film The Day After Tomorrow.
The Northern Hemisphere owes its temperate climate to the North Atlantic current. Heat from the sun arrives at the equator and is carried north by the ocean. But global warming is melting the polar ice caps and disrupting this flow. Eventually, it will shut down, and when that occurs, there goes our warm climate.
Day After Tomorrow, the film, the premise is based on science, but it was greatly overblown. And frustrated a lot of climatologists.
The Gulf Stream system is a very important part of the climate machinery of our planet because it transports huge amounts of heat and is the reason why the whole region around the northern Atlantic is warmer by several degrees centigrade compared to what would be normal on that latitude. There has been a concern since the 1980s that this system might be unstable, and that due to the global warming, we are actually slowing down the Gulf Stream system.
What if what we do now is introducing so much fresh water into the North Atlantic that the North Atlantic current would sort of stop? That would make it terribly cold in Denmark, where I come from, because all of Northern Europe is placed at completely unreasonable latitudes. Just because we have the North Atlantic current, we have remote heating, so to say. If that's going to be switched off, we're getting very, very cold. But still, the Earth could get warmer on average. It's just a distribution problem now. In principle, there's no reason why the Earth could not get warmer, but still Northern Europe and North America could get cold. Still, that area is not large compared to the global area.
We are 50 years to 100 years ahead of schedule with the slowdown of this ocean circulation pattern relative to what the models predict. Why might that be true? Well, one of the things that the models also aren't capturing is the rate at which we are losing ice from the ice sheets, the West Antarctic ice sheet and the Greenland ice sheet.
Greenland melting actually can explain a significant fraction of this freshening of the North Atlantic just south of Greenland.
If it's in Greenland, it flows into the North Atlantic. It freshens those waters, which lessens the density of the waters at the surface, which inhibits the sinking motion in the subpolar North Atlantic that drives that global conveyor belt.
The current depends upon a delicate balance of salt and fresh water.
We all know that.
Yes, but no one has taken into account how much fresh water has been dumped into the ocean because of melting polar ice. I think we've hit a critical desalinization point.
The critics say there's uncertainty, and uncertainty is a reason we shouldn't act on this problem, when in fact the uncertainty has in general broken against us. As we learn more, as we get better observations, we're seeing that things are happening sooner than we expected, faster than the models predicted, and sometimes there are unforeseen consequences. The fact that the Greenland ice sheet is losing ice through melt into the North Atlantic earlier than the models suggested it would means that you're freshening the North Atlantic earlier than the models suggested it would, which means you're slowing down that ocean circulation pattern earlier than the models suggested we would. So once again, the more observations we get, the more sophisticated our models become, the more we're learning that things can happen faster and with a greater magnitude than we had predicted just years ago.